Good morning. We're here to talk about the Gold's Aquaforce unit and go over some of the basic functions and functionality of how this unit operates and works. Okay, starting off with our user interface here, we've got our main disconnect for our power coming in. So in the event that you ever need to service any of these units or cut power to the service, it's going to be right here on this main disconnect. We have our user interface screen here, which is our displays our set point pressure at 170 psi to be able to deliver pressure to the upper floors. You've got your pumps in sequence here from left to right, 1, 2, and 3. With those pumps, we can see the pumps that are active on the screen here. They have a green box around them, and they are showed as being enabled. This one currently is in a disabled mode, so it's not up and running. In order to simply enable and disable all pumps, this is a touch screen display. You just touch on the screen itself, and it'll prompt you and allow you to make any changes to the system as needed. Okay, a few other items we have are going to be the actual VFDs themselves. These are the VFDs that are going to run your pumps, which interface with this main cabinet here, and they're going to run your pumps at speeds according that are needed as far as like system pressures, drops and pressures in your system. Now, if there's ever a need, you can always cut power to each individual drive on the drive itself. If the drive needs to be taken out of service, or if there's something that arises in the system that we need to cut power to in an emergency basis, it can be done right out the drive itself or from the main disconnect right here. You've got on the system, we have a suction gauge here, which is going to display our suction pressure coming into the system. That will tell us, inbound city pressure at this point. We have our isolation valves for each pump. This is on the suction side. So in the event that you have to take a pump out and service it, you can isolate the pump with this valve. There are valves on the opposite side, which I'll cover as well. That way the pump can be removed. It can be put into service, and once that change has been made, it can be put back in and then brought back into service. Again, you would come back to your user interface, enable the pump once it's up and operating, and then the Aquaforce will take over and it will do what needs to be done. From a programming standpoint, everything is all touch screen. You have menu listings that you can go through that will get you into the desired screens as far as your performance. We have different screens like your quick setup. You can go in there and we can actually change out your set point pressures. We can even do our no flow shutdown, which essentially is when the system has reached set point for a minute or better and we're maintaining it without the pumps oscillating up and down, what will happen is it'll go into a no flow shutdown saying, I'm not using any water in the system currently, there's no demand, I'm going to idle. And then once the pressure drops, I'm going to come back up into service and provide pressure for you. On the other different screens, we've got obviously alarm setups. So let's say, for example, like one of the VFDs fails. We're actually showing a comm fault right now because one of the VFDs is down. So that is one of the function of the actual alarms. It will prompt you on the screen here. It will prompt you. You do have the capability to reset it. Now, with that alarm, it will display it on the screen, and you will have an audio fault as well here. Okay, so this buzzer will go off and chime whenever there's a fault or something that's come up. To silence it, you simply just press this button. That'll silence the alarm, and then you can come in and address whatever issue you may have. It does have an actual, help function built into the unit. So if you go into service, and we go into alarm, you have all your different settings for your alarm settings. Okay, we've got our low pressure cutout, we've got high system pressure. So if the system pressure exceeds what our set point is by 15 pounds in this case, for more than 60 seconds, it's going to go ahead and shut the system down, saying we don't want to exceed our set point and cause any damage to the system. Okay, same with with your low suction. We've got a low suction proof timer, which is built into this unit. So if your suction pressure is lower than 5 psi, which we've got it set to, 10 psi currently, it will trip the VFDs, telling them, hey, we've got a lack of water We don't want to run the system because we do have the potential for damage, not only to, you know, our system in general, but the actual pumps themselves. High level, again, you've got high system pressure on the suction. So if our suction pressure exceeds this value here, which is 67 psi, it's going to say, hey, we've got a very high suction pressure coming into the system. That's going to create some problems further on down the line. We need to go ahead and just address that and see what's going on. It'll go into an error, and that will be produced on this screen down here as well. And with that, every time this system produces a fault, like I said, it will display it here. You do have the ability to reset it. And on some of the, depending on the type of alarm that it manufactures, you have two different types. You have what's a non-critical alarm, which is basically just an alarm that's more of a warning. In this case, like the VFD fault, it's more of a warning saying, hey, one of our units is down and not running, so that's not considered a critical fault. So we could simply just reset it, and then it'll go through the proof timer, and if it produces a fault again, it's going to, you know, sound the alarm, produce a fault on the screen, and then it would have to be addressed. Now, critical faults are going to shut the pumps down to keep them from running. And during that point, you would have to physically be here to address whatever the fault is, because this unit is not going to allow it to run at all at that point. It's considered a critical fault. Critical faults being, you know, motor failure, a VFD failure, pump failure for whatever reason, a bound pump. It could be a number of different things.
Something major.
Yes, something very major. Yeah, it could even be if it's running full speed and it's not maintaining set point, it considers that like a broken line, so it's going to fault out, and that's considered a critical failure. It does not want to run at that point. Other than that, really on the user interface, all this is contained in the manual itself. The manual is one of the best keys to reference. It gives you points on all of your VFD failures, on any failures that you may have in the system. You can look up your failure codes. It'll display what the failure code means. It'll give you remedies as how to fix it, and then it'll give you the steps that you need to take action and get that done. Really, on this end of things, that's all we really have to point out. Okay, we're going to cover the pressure tank now. The reason for the pressure tank in the system is so that the pumps can come up to pressure and retain pressure once they've hit set point and shut off. And I would imagine in a building this large with consumption of water, they may never shut off. But the vessel is here so that you have, you know, actual air charge in the line, so that in the event that the pumps do build pressure and shut off, this will actually give you a bit of drawdown in the system, so that the system can just quiet down and just go into basically like a sleep mode. You do have an indication for your system pressure here on the gauge, and that's just going to read basically line pressure coming off the system at that point. On the tank, there's really not much needed in the way of, you know, I guess servicing the tank. The one thing that does need to be checked periodically, just like the tires on your car, is obviously the air pressure in the tank.
So the gauge in here for a valve?
There is, yes. There's a Schrader valve that's in here that you can access, and that's obviously to read pressure in the tank and to air it up. This is a bladder tank, yeah. This is what they call a full acceptance bladder tank, so it'll take, you know, full acceptance of water. In this tank, with our system set point at 170 pounds, we were just discussing earlier, where you want the set point pressure in this tank is 160 psi. Now when you do that, the tank needs to have 0 system pressure on it. Otherwise, you're going to be reading system pressure off the bladder itself. So to charge the tank and to double check pressure in the tank, system pressure has to be 0 against that bladder to get an accurate reading and make sure we're getting that in there correctly. Okay, I will move on to this other side now. Okay, on this side we're going to be covering some more of your isolation valves. This is our main discharge header for the unit here. These will be our opposite end of the isolation valves for the discharge side. So again, kind of going back to the whole service aspect of things, if the pump needs to be isolated, we're going to shut off both suction and discharge valve, and then we can address the pump as a whole. We do have our check valves on this side, on the outgoing side of the discharge, and you do have the means to obviously isolate those as well if they need to be serviced and replaced. On this side, we have thermal purge valves on each pump. And what that is if the pump goes into what we call a deadhead situation and the water is not being moved in the system, it can heat up inside the pump. And that thermal purge valve is going to go ahead and release the pressure off the pump so that we don't have any damage to the pump as far as heat and pressure coming off of it. So what that does is it actually blow off through this line here, and that goes right into your floor drain over there. On this side as well, for motors, as far as from a serviceability standpoint, really what we want to do is just make sure we're not seeing any water leaking. That would indicate we've got a broken seal and it needs to be addressed. The other thing is we do have grease zerks for our bearings on each motor that need to go ahead and be serviced every year. And it doesn't take much. Your grease is actually listed right on the tag of the motor, and it'll tell you the type of grease that you need to use for those bearings. And it doesn't take more than a single squirt in each zerk.
Okay.
They are open face bearings, so we don't want to overdo it on the grease because that grease will work its way inside the motor. So just one squirt about every 6 months is what's recommended from the factory, and you should be good to go on this side. I mean, other than that, we do have our discharge gauge here, which indicates our discharge pressure. Really, that's all that we got on this side as far as that would cover.
This right here is our 6-inch main coming in from the city breaker. It comes in, hits a bypass for your retail area. That'll feed your water heater for these common areas, bathroom, and there's mops in here. It continues out, catches your bypass for your express line going from 20 to the upper floors all the way to 30. Continues on, gives you a bypass that'll go from ground level all the way to 19 with your main dispersion on level 9. Continues on, comes back in, feeds your suction side on your pump. So this is your low suction side on your pump coming in. Goes into your pump, obviously, pushes up. That's your high discharge already coming out of the pump. So you're coming out at 170 already, coming out. Hits your lower side at a 115 PSI. So this is the one that's on level 8 that'll drop your PSI down to hit 19 for your lower units. So this actually will get your units on level 8 through 19.
Okay.
Then this will be our express line with 170, which goes out, branches off on level 20, and then it'll go all the way to level 30.
Okay.
And ends up at your pool equipment room and your 2 penthouses up at level 30. That is it for this one. This right here, your shaft behind here is basically where your main water lines come up. Your express line turns and continues going up, and your main shut off for these ones right here turns off here and branches off both ways. Goes west and goes east, catching units as it goes. These right here are your access panels. Each individual unit has its own little main shut off butterfly valve that catches from 8, 9, all the way to 19. So that'll be an access panel for this one. This right here will catch your unit behind here. Probably that unit most closely by. So it'll branch off to that. You can see the pipe up there. I mean, some of these are a little bit pain in the butt, but they're back there up there. Same thing here. This will branch off, continue off that way. This will branch off, continue. And take in consideration, some of these are water and some of these are gas.
Right.
So they switch around. Same thing here. Goes back here, goes back inside. This right here, it's closed out, turn your hand. And they're usually targeted right about your water heater area. So that makes it a little easier on you. And we should have one on that other side right there, same thing. This is your hybrid water heater for every unit. Same water heaters in every single unit in this building. This is your display. They're already preset. All you do is hit the breaker, set it on hybrid, and they're already set at 120. That's it. Got your relief line. Relief line goes into your wall, stubs out at the bottom, into your hub drain at the bottom, which also contains a trap seal for the smell. You got your main shut off to your whole unit, it's up here. This will shut off all the water to this building. If you were to shut off the valve down below, it'll only shut off the hot water to your bottom, but you still have cold water inside the building for any kind of maintenance issues that you might have further in. Expansion tank. These 2 hoses back here, I mean, they're kind of hard to view, but we have a 5/8 clear hose and a 7/8 black hose. which are condensates for this hybrid heat pump. That's all they are. You got your black holes with your 7/8 is your primary condensate drain, and your 5/8 is your overflow in case for some reason it should clog up or something. It does have a backup overflow on it. And that is it.